Okay, so this is probably going to be a little bit rough, but I'm going to go ahead and do a recording for basically all of the notes we're going to take this week in eighth grade math. And it's going to be all about exponents. So if you're following along, hopefully you're taking notes as well, because when you guys get back, you will have to probably, I'm hoping you'll get back before the test we take on this, but you will want these notes with you either way. So I would title it exponents. I'm going to go a little bit quick through all of this. So you can go at your own pace. You can pause it if you need to. If you need to look at a specific slide, you can rewind and go back. But this is just going to be a quick kind of run through of everything we're covering this week. Next week, we'll have decided what we're going to do as far as potential Zoom classes if we do that, or if we're just going to do more recordings. If we do more formal recordings next week, I will slow them down, do them day by day. So they'll be in smaller chunks. So for today, this will be a little bit rough, but hopefully you guys can make it work. This stuff isn't too terribly difficult, and a lot of it is review, so I'm hoping we'll be able to get through it pretty quick. So first things first, what exponents actually are. We're going to skip that last single part because it doesn't really matter. So sometimes in math, we need to multiply a number by itself one or more times. And to do this, we use an exponent. You probably have already seen a decent number of these, but the ones you're most familiar with are going to be squares. So right here we have 8 squared, 3 squared, 5 squared, and 10 squared. Hopefully you guys all know how these work. One of the most common mistakes that kids make during this unit and with exponents in general is they look at 8 squared, for example, and think, okay, this is equal to 8 times 2, which is 16. This is not correct. This is bad. This is a mistake that all kids make. You might make it at one point or another during this unit, but try to avoid it. This means 8 times 8. And we're going to talk about it in more detail going forward. So in these problems, each of the 2's is an exponent. So the 2's in a square problem are exponents. So this is the breakdown of an exponent. We have in green here is our base, that's the 3, and up here is the 4, or the power or the exponent for the 4. So the base is the number that's being multiplied. The exponent or the power tells you how many times to multiply it. So the base right there, the power, exponent, or power right here. And these are vocab words. We're going to use these a lot throughout the term. That's why they're in colors, green and blue. So make sure you know what these mean. Base is just the number being multiplied. Exponent or power is the number of times we're going to multiply it. So this whole thing together often gets referred to as an exponent. This can sometimes be referred to as an exponent on its own, or it will be the power. That'll be more common, generally speaking. Okay, so exponents are basically just telling us how to write a specific number that's being multiplied by itself multiple different times. So this is a lot of text, but basically what it tells us is the base, that's here, is the number being multiplied, and the power tells you how many times to multiply it. So the example here we have is 2 to the 4th. So what this means is we're going to take 2, that's our base, and we're going to multiply it by itself 4 times. That's our power. So we have 1, 2, 3, 4 2's. So 2 times 2 times 2 times 2. 2 to the 4th is written in what we call exponential form. That's also in yellow. That's a vocab word. It's part 1. We'll talk about that a lot. So basically, if you see a number raised to an exponent, it's in exponential form. The 2 times 2 times 2 times 2, that's actually still, you can still write equations that way. That's called expanded form. And both of those equal 16. You'll notice that this has a lot more stuff to write than this. Basically, the reason we developed exponents is just because it takes a long time to write all of these out. Mathematicians are notoriously lazy. This comes back over and over again. If we can shorten something, we will. And that's one of the ways that we manage to shorten exponents. So really quick, this is just a quick concept check we did in class, but you guys can follow along a little bit. If you want to pause before you actually see the answers to the questions, I would recommend doing that. So the check here is this term written in exponential form or expanded form? We have 3 times 3 times 3 times 3 times 3. I'll give you a second if you want to pause, but hopefully you guys already figured out. This is in expanded form. So we have all of the numbers actually written out individually. That is in expanded form. And then if you want to try writing in an exponential form yourself, go ahead and do that now. Pause the video if you need to. But I'm going to go over it in about 2 seconds. And then, yeah. So to write this in exponential form, we have 3 to the 4th. Our base is 3. That's the number being multiplied. So that's how we get this number. And then we count out there's 1, 2, 3, 4 instances of it, so it's raised to the 4th power. The number that represents the base, I already talked about that, it's the 3. And so when I ask you what number represents the power, hopefully you can pretty quickly say that is the 4. So specific types of exponents. There are a few special cases that are worth our attention. We'll go through, I think there's 4 of them that we're going to talk about. The first one is one you're probably familiar with, that's squares. So that's any number raised to the second power. And we talked a little bit briefly in class about why we call this a square. And the reason is actually because if you take a line segment with a length of, let's say, 3, and we're looking at, so in this case, we're looking at 3 squared. We're going to see why is 3 squared called 3 squared, or instead of just 3 to the second power. Which, by the way, you can say to the second power, but squared is a little bit easier. The reason for this is if we build a square out of this 3, so we take this number, this line segment with a length 3, turn it into a square, the area of that square is equal to 3 times 3, which is 3 squared, or 9 in this case. So that's why we call it squared. Using that, you can probably fill in what I'm going to do next, which is a number raised to the third power, which we call a cube. So for example, the volume of a cube with a side length of 4 is equal to 4 times 4 times 4, or 4 to the third. And so here's that cube right here. We have a height, or a length, I guess, of, it's side length. So length of 4, width of 4, and a height of 4, depth of 4, whatever, however you want to think about it. This doesn't really matter. Point is it'd be 4 times 4 times 4, which would be 4 to the third, which would be 64. There are a few other special exponents. Exponents with the base of 1. So this one, I hopefully don't need to go over a ton, but if we take 1 and we multiply it, let's say we take 1 to the 51st. Well, this is going to be equal to 1 times 1 times 1 times 1, dot, 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 51 times. And hopefully you guys know right off the bat, 1 times 1 is 1, times 1 is 1, times 1 is 1. No matter how many times we multiply this, it's going to be 1. So if the base of an exponent is 1, the answer is always going to be 1, no matter what the power is. Later, we'll talk about 0 powers and negative powers. That's going to be next week. But even if you have like 1 to the 0 or 1 to the negative 17, it's still going to be equal to 1, no matter what you do with it. And yeah, this is because no matter how many times you multiply 1 by itself, you're still going to get 1 as your answer. Powers of 1 are another way of doing it. So when the power itself is 1 instead of the base, powers of 1, the base is not being multiplied by anything. So this means that any base raised to the power of 1 is equal to itself. 3 to the 1 is 3. The next one has an error on it. I still haven't fixed it. I will fix it as soon as I'm done with this because I keep forgetting. 5 to the 1, this should be a 5. It is not 1. So 5 to the first power is 5. 1,342.5 to the first is equal to 1,342.5. And negative 2 to the first is equal to negative 2. Now, the last example, we're bringing in negatives all of a sudden. And negatives actually are really interesting when it comes to power. So we're going to look at those next. If we have a negative number as a base and we're raising it to a power, our answer is going to be heavily dependent on what that power is. And I'm going to show you why. If we have negative 3 squared, what that's equal to is negative 3 times negative 3, which gives us positive 9. So we have a positive answer right here. If we have negative 3 cubed, we have negative 3 times negative 3, that was positive 9, times negative 3 again. And you'll notice that this negative, or this 27 here is negative. This is very, very important. When we have this third power, the number becomes negative again. And the reason is we're multiplying it by another negative number. So if you go 3 to the fourth, you're going to multiply this by negative 3, and you're going to get positive 81. So it's going to switch back and forth between being positive and negative. And there's actually a shortcut way of doing this. We talked about it in class before I went to it. I'm just going to go ahead and flip to it for you guys. So it turns out that when a negative number is raised to an even power, the answer will always be positive. So for example, if we have negative 5 raised to the power of 8, our answer is going to be positive. I'm not going to do 5 to the 8th right now because that's a really big number, but the point is you're going to get a positive out of this. When we raise a negative number to an odd power, however, the answer is always going to be negative. So if you have a negative number, let's say negative x, raised to some power, let's call that power y for right now. If y is even, your answer is positive. If y is odd, your answer is negative. And this is all the time, no matter what the numbers are. As long as you look at this power right here, if it's even, your answer is going to be positive. If it's odd, your answer is going to be negative. Now, that's only when we're talking about squaring or raising a negative number to a power. So these are the algebra terms for what I was just showing you guys. This is an example. So negative x raised to the 5th would be the same as negative x to the fifth, whereas negative x to the sixth is going to be equal to positive x to the sixth. They're going to be the same, just because the answer will end up being positive either way. So the Excel practices that go along with that are D1 and D2. And since we have so many kids on quarantine and things are a little bit weird this week, I'm just going to give you guys the list of 4 required IXLs and tell you to go to at least 70 on each of those. Since you guys are at home and on quarantine, if you want to practice it further, that's probably a good idea. The more practice you can get while you're gone, the better it's going to be for when you get back, the easier it'll be to catch you up all the way. But this is a good place to start. So D1 and D2 are for just that basic stuff. If you want to pause here, take your time to go look at those, maybe continue the video later on, take a break, whatever. This would be a good spot to do it. But I'm going to go ahead and go through the next 2 things here as well, and then we'll be done for what we're going to do this week in class. So next up, we have multiplication law. So sometimes when we're using exponents, we end up having to multiply them. So for example, let's say we have 2 squared times 2 to the third. And if you're still following along with notes, this is a very important part to start writing down. You could start just right here with what I've underlined. You don't have to go all the way from the top on this slide. So if we write this in expanded form, we have 2 squared times 2 to the third. What we get is 2 times 2. This is the 2 squared part. Times, and then we have 2 to the third right here. 2 times 2 times 2 times 2. Now, because all of these are multiplication, and we're just multiplying all the way through, normally if you're doing order of operations, if these were all different numbers, you'd have to do whatever's in parentheses first. Since all of it is multiplication, we're using all the same number, we can actually rearrange this. We don't need the parentheses. It doesn't matter what order we multiply in. So this is basically the same thing as 2 times 2 times 2 times 2 times 2. That's an exponent in expanded form. So we can just rewrite this as in exponential form. We have 1, 2, 3, 4, 5 2's being multiplied. So we can rewrite it as 2 to the fifth, which means that overall 2 squared times 2 to the third is equal to 2 to the fifth. And you'll notice here that the power of the answer is equal to the sum of the powers in the original equation. And that's what multiplication law really talks about. So if we multiply 2 exponents with the same bases, the result is the base raised to the sum of the powers. That's a bunch of fancy math words for basically saying, when you have a base that is the same, so in this case we're using a, raised to a power b times the same base raised to a power c, the answer is equal to a raised to the power of b plus c. So we're going to look at some examples. Here we have 3 to the fourth times 3 to the seventh. So all we're going to do is first identify the base. Since they're both base 3, we can actually simplify this. So we're going to have a base of 3, and then our power is going to be the sum of these 2 numbers. So we're going to have 4 plus 7, which is equal to 3 to the 11th. And there you go. Without doing any fancy math, you've solved this. Now, you could, if you ever forget how to do this, just write these out in expanded form. So you could actually write 3 times 3 times 3 times 3, and then you could do times, and then 7 3s, which I don't want to do right now. Count them all up, put it back into exponential form, and that would work too. But this shortcut is going to be really, really helpful. Here's another example. We have 4 to the 9th times 4 to the 11th. So our base is 4. These have the same base, so we can multiply them. So we have 4. And then we're going to do to the 9 plus 11. You can add those together. You have 4 to the 20th power. So that's pretty much the basics of multiplication law. There is one thing you need to watch out for, though. And that's why this slide has a big warning up at the top with 3 whole exclamation marks. That's how you can tell I'm being serious. If you multiply different bases, there is no way to simplify your equation. So for example, 2 cubed times 9 squared cannot be simplified without solving it. The reason for this is if we write this out, we have 2 times 2 times 2 times 9 times 9. Ignore that weird little dip thing. We'll just make this a really big times sign. So we can still put the 2 to the third back together, right? This is 2 to the third, this is 9 squared, but we can't combine those any further than we have. Now we could actually solve these. If we had a calculator, we could just plug these in. 2 to the third is 8 times 8 squared, or 9 squared, sorry, is 81, which gives us 648. So if you wanted to do that on a calculator, you could pretty easily, or in this case, you could actually probably do it by hand if you wanted to. Some big numbers wouldn't necessarily, I wouldn't make you do something like this, but you could do it. So what we can do though, is if we have something like this. So we have 2 to the third, we have 3 squared, and we have 3 to the sixth. Now the 2 to the third is a base that there's nothing else that has that same base. So we can't do anything with that. We can't simplify it. We can't combine it. It's going to stay the same no matter what we do. I could write all this out and show you, but I think you guys hopefully will get the point at this after this many examples that we've done. So then we have 3 squared and 3 to the sixth. And these have the same bases. We have a base of 3 and we have a base of 3. So both of these have bases of 3. So what we can do is use our multiplication law to simplify and combine these two terms together. So what we do is we raise 3 to the power of 2 plus 6. Again, we're just adding the power of 2 plus the power of 6, which simplifies to 2 cubed times 3 to the 8th. Ta-da! We have managed to simplify a term with 3 different things. Now, this, if we have a question like this on the test, this would be the answer that I'm looking for. Unless I specifically say, give me a numerical answer here, this is where we're trying to go. We're trying to simplify exponents. We're not necessarily trying to solve them outright. Because again, you could multiply this out, you'd get 8 times whatever 3 to the 8th is. I don't want to figure that out. That's a huge number. It's like 81 squared, which is just big. We don't want to do that. So I'm not going to bother multiplying those out. But 2 to the third times 3 to the 8th is an answer. And with a calculator, it wouldn't be that hard to calculate. You might not know where the button is for it, but if you were in class, I could show you. I'll make sure you know where it is when we get back, though. So next, we're going to move on to division law. And division law, it's a little bit more complicated to explain. We're going to have to use some fractions. But the overall process and the shortcut for it is actually pretty much the exact same as the last one. It's just flipped. So let's see what happens when we try to divide exponents. Let's say we take 2 to the 5th, and we divide it by 2 to the 3rd. So if we write this out in expanded form, what we get is 2 times 2 times 2 times 2 times 2. I'm going to lose track of the 2's, divided by the other set of 2's. So we have 5 2's on the left, divided by 3 2's on the right. Now, we can rewrite this as a fraction, and that's going to help us cancel out some 2's. So we have 5 2's on the top, and we have 3 2's on the bottom. And hopefully, you guys learned when you were either reducing fractions or working with division, or just in general throughout your math classes before this, you've learned that if you have numbers like this being multiplied on the top and bottom of a fraction, you can cancel anything you see on both sides. So I can cancel out 3 of the 2's from the top with all 3 2's from the bottom. That would leave me with, be careful here, this is a 1 on the bottom. If you cancel everything out, it becomes a 1, just to refresh your memory. So we're left with 2 2's on the top and then just a 1 on the bottom, so we can just write it as 2 times 2. And that leaves us with 2 squared. So overall, 2 to the 5th divided by 2 to the 3rd is equal to 2 squared. And maybe you can already see the pattern forming, but we'll go ahead and go to the next slide anyway. So it turns out when we divide exponents with the same base, the result is the base raised to the difference of the powers. And that's a fancy way of saying when we're dividing exponents with the same base, we just subtract. So in this case, b minus c. In the previous case, we had 2 to the 5th minus 2 to the 3rd. That gives us 2 to the 5 minus 3, which is 2. So here we have 3 to the 7th divided by 3 to the 4th. So again, we have our same base, so we can actually do stuff with these. So this is going to equal 3 to the power of 7 minus 4. 7 minus 4 is 3 to the 3rd power. Okay, or 3 cubed. You can say that either way. Here we have 5 to the 12th divided by 5 cubed. So we're going to have 5. Again, we have the same base, so we can do these. To the 12 minus 3, which is equal to 5 to the 9th power. And there we go. That's basically how division law works. It's pretty simple over and over, or overall. So the IXLs, apparently you don't have a slide for it this time, sorry. The IXLs for division law and multiplication law are D8 and D9. And it's the same on these two. There is an assignment for it on Google Classroom. So these are the practices that I want you to get through. There's also in the Google Classroom an assignment called A Month of Exponents, as well as your homework for the week, both of which are Google Docs. I made copies for everybody that are online. So like digital copies, so you can just go in, type on it directly, and then just submit it. So your goals for the week, I will list them all out here. So if you want to like take a picture or something, you have the IXLs, which are D1, D2, D8, and D9. And all of these you want to go to 70 or higher. This will get you a 4. Again, since you're on quarantine, you're not getting as much time in class to do these practices, you might want to try to take it to like 80, 90, maybe 100 if it's something you're struggling with, or you really want to make sure you have down. But this is one of our goals. This is probably the most important one because it's the basic skills practice. The other things might take a little bit of extra help. The other assignments are the homework for week 3, which is just week 3 homework. It's in the Google Classroom. 4 questions, shouldn't be too terribly difficult. Most kids got it done in like 6 minutes in class. So chances are you guys won't have too much of an issue with that one. And then the month of exponents. Now this one is a tricky assignment. Those of you that are online, which is, I believe, most of you, somebody might watch this as a review. I want you to try this last. Do give it your best shot. It is something that you might need help with, and that's perfectly fine. But I do want you to at least give it a shot on your own while you're gone. And that's all I've got for this. So hopefully we'll know more by later you're probably not gonna watch this tomorrow. Hopefully by late Wednesday, we will know what we're doing for the week or for next week. We'll get you more information then, but for now, this should cover everything we're gonna do in class this week.